In this video, the customer application used on the smartphone of a fish market customer is presented. This application has been developed in the context of the Smart Fish Farming project with ID 16242 funded by the HFRI Institute. Let's start the application. The purpose of this application is to help consumer in a fish market get more information about the fish that exist on the bench or the shelf of this market. The application exploits the hardware-accelerated shape alignment module that is developed on a ZCU 102 FPGA development board. The board exists in the premises of the aquaculture, and its main purpose is to analyze the shape of a large number of fish in the aquaculture in order to extract information including dimensions, weight, shape malformations that may indicate the fish health condition, and also it can distinguish between fish species variation. The purpose of the customer application demonstrated in this video is to send photographs of fish existing on a market bench to the FPGA development board through FTP. The shape alignment module of the FPGA board detects the new image file arrived from the customer application, analyzes it with shape alignment, and from the ratio of the distance between specific landmarks, for example fish nose, fish top or bottom, it can distinguish between species variations, for example farmed or open water sea bream. If the distance is known between the smartphone camera and the fish, then the size of the fish can also be estimated. In future work, information about the freshness of the sea of the fish can also be estimated from color analysis. Now you can see the main page of the smartphone customer application on an Android emulator that is used by the Visual Studio 2022, where the customer application has been developed using Xamarin Platform and C#. What you see in the main page is the HFRI logo and the project identity. Below there is a button that can be used to select a stored photograph. For simplicity, we assume that the photograph of the fish has already been captured. Below this button, there are the FTP address and the account login and password that will allow to the application to be connected to the FTP server that exists on the FPGA board. In order to be able to demonstrate the communication, we use, instead of an FPGA board, a second computer as an FTP server. The FTP directory, where the photographs arrive, is this one here, as you can see, and is initially empty. We start FileZilla server to accept our FTP requests. Since we have started FileZilla, now let's select the fish photograph on the side of the customer application. If we know its distance from the distance of the fish from the smartphone camera, we can change this field here so that the dimensions can be also estimated. In this case, we would select Analyze plus Size button to send the photograph to the FTP server along with the distance. If we just want to estimate fish species variations from the distance ratio between specific landmarks, we can just press Analyze No Size button that sends only the photograph without any distance to the FTP server. So let me press the Analyze plus Size. On the side of the FTP server, you can see that two files have been arrived in the directory of the FTP server. The one is the image of the fish, and the second is a text file with the distance of the fish from the camera. Now, normally the shape alignment module on the FPGA board will analyze the photograph and create another text file with the results. Let's use an already prepared one, like this one here on the desktop, which has these messages here. I move it into the FTP directory, And now on the other computer where the customer application emulator runs, back to the customer application. So let me press get results. Okay, and now you see that the contents of the results file showed you earlier in the other computer appears now in the customer application at the bottom of the customer application.